Problem 1.13. In this problem, the volume rate of flow Q through a pipe containing a slow-moving liquid is given by the equation Q equal pi r to the fourth delta P over 8 mu L, where r is the pipe radius, delta P is the pressure drop along the pipe, mu is the fluid property known as viscosity, and L is the length of the pipe. Our goal is to find the dimensions of the constant pi over 8, and we need to determine whether this is a general homogeneous equation. Basically, we need to determine it is dimensionally homogeneous. In order to solve this problem, we're going to write the dimensions of each quantity, and we're going to substitute it in the original equation. We need to find the dimensions of the constant pi over 8. Since it's a constant, we got to prove that it's dimensionless. So let's start with Q. Q is volume flow rate, so it basically means that is volume divided by time. We got the radius. Radius is simply a length. We got pressure. Pressure is simply force divided by area, so it's force divided by length square. We got mu. If we keep it in the FLT system, we're gonna just write it as F force time divided by length square. And lastly, we got length. And we're going to substitute all of this one into the main equation and prove that pi over 8 does not have any dimensions. So we start with Q. So Q is length over 3 times to the third divided by T. We're going to write it for pi over 8, right? So that's the constant that we're looking for. R is going to be length to the 4. Then we got pressure, which is going to be force length square. We're going to divide by mu. Mu is equal to force time length divided by 2. And lastly, we have length. Okay, now let's see how things cancel out. Force and force cancels out. L to the fourth divided by L to the second becomes L to the second. And L to the first, and this becomes, this cancels with this, and this becomes to the first. So we keep the left side exactly as we had it. So that's what we're looking for. The unit, the constant pi over 8. And now let's rewrite the equations over here. So over here we have L to the third. L to the second up in the top, L to the second, then divided by T over L. So if you notice this is L to the first stayed in the bottom. Now if we simplify this, we notice that this becomes L to the third divided by T. And that is exactly what we're looking for. So notice that the unit, the dimensions that we have for Q, L to the third divided by T, and that is exactly what we ended up on the right side. Once again, proven that the constant pi over 8 is dimensionless. So notice that if we have canceled these two sides, the dimension of pi over 8 will be equal to 1, which basically indicates that is dimensionless. And since that is the case, this will be a dimensionally homogeneous equation.